Hello friends, today we are going to learn a new chapter, lines and angles. Before going, we will discuss few basic terms like point. Actually, point is an undefined term. You cannot define this point. But actually, point is an exact location. It is an exact location and it is represented by a fine dot made by a sharp pencil on a white sheet. See, for example, this is a white paper and this we represent point by A. So, A is a point. So, it is just a location. It is represented by a fine dot. See, actually this is not a point. It is a representation of a point. It is represented by a fine dot made by a sharp pencil on a paper. So, we can say here A is a point. So, it is undefined term. Now, we will discuss line. What is line? Line is a collection of points. See, 1, 2, 3, 4. In this way, it is a collection of points. So, line is a collection of points which has only length. It has no breadth. It has length. It has no breadth and thickness. It has no breadth. It has no thickness. But here there is a little confusion. A questioner asks, sir, can you measure a line? No. See, for example, this is a line. We can't measure. Why? Because it does not have a definite length. It extends endlessly in both the direction. Okay. So, it has length means out of 3-dimensional, 3D. It has only one dimension, that is length. It has no breadth. It has no height, that is thickness. And it has no definite length. See, once again, it has a length. Considering out of 3-dimensional, it has only length, but it does not have a definite length. You can't say this line AB is 5 centimeter. Why? Because it extends endlessly. See, it extends here in this direction, it can go out of the paper this way. Here it also extends endlessly and it can go out of the screen. So, it has no definite length. Or we can say it is a straight path that is endless in both the direction. And it is represented by symbol line AB, or it also can be represented by a symbol line BA. Have you got it? So, we can say that it is the collection of points which has only length. It has no breadth and no thickness, but it does not have a definite length. It has length, but it does not have a definite length. You can't measure that line. Okay. Then comes ray. So, what is ray? See, ray is a part of a line. See, this is a line. I have drawn this part of a line. So, ray is a part of a line which has one end point. And this end point is called initial point. And it extends endlessly in one direction. Why? Because it has one end point. Whereas in this case, we can say line has no end points. It has no end point. Here it has one end point. So, we can say in short, ray is a part of a line having one end point and it extends endlessly in one direction. It is denoted by symbol ray AB. Okay. Here A is an initial point. Here we can't say ray BA. Why? Because B is not end point. So, this is not the symbol we use to denote the ray. This symbol we use. Then comes line segment. So, line segment is also a part of a line. See this line AB. It is a part of a line which has two end points. It does not extend in any direction. So, we can say it has a definite length which can be measured. You can say this line segment AB is equals to 5 centimeter. That is, distance between end point A and end point B is 5 centimeter. So, we can say it has two end points. It has a definite length and it is represented by a symbol called line segment AB, or line segment BA. So, what is point, what is line, what is ray, and what is line segment? So, point is an undefined term, it is just an exact location, okay, and it is represented by a fine dot. Now, line. What is line? So, line is a collection of points which has only length, no breadth and no thickness, which extend endlessly in both the direction. It has no end points. Ray. Ray is a part of a line having one end point and extend endlessly in one direction. Line segment is a part of a line having two end points and it has a definite length. Okay. Now, if you want to see the difference, we want to see the difference between line, ray and line segment. So, from above theory, you can say what are the difference. First one, line. So, we can say in case of line, it has no end points. No end points. It has no end points. Here it has one end point. It has two end points. So, this is one major difference we can say. Now, a line does not have a definite length. No definite length. Here also we can say no definite length. In this case, we can say line segment has a definite length. It has a definite length. So, here first difference, second difference, third difference, we can say we cannot draw a line on a paper. We can simply represent it by a diagram. We cannot draw a line on a paper. Here also seeing same thing, we cannot draw a ray on a paper. So, here we can say a line segment can be drawn. A line segment can be drawn on a paper. Fourth difference, we can say representation of a line. So, line is represented by a symbol AB. Diagram we can say here, see A and B. Ray is represented by a symbol ray B. Diagram we can say here A, this point B. Line segment is represented by a symbol line segment AB, and this is the diagram. So, this is the difference between line, ray and line segment. First difference is based on points. It has no end points, one end points, two end points. Second is about length. It has no definite length. Ray also has no definite length, whereas line segment has a definite length. Here line cannot be drawn on a paper. Why? Because it extends endlessly in both the direction. Ray also cannot be drawn on a paper. Why? Because it extends endlessly in one direction. Whereas in the case of line segment, it does not extend endlessly in any direction. So, we can draw line segment on a paper, and these are the symbols. Okay. Now, we have learned in lower standard collinear points and non-collinear points. Okay, what are collinear points? See, 2 points are always collinear. Just you plot 2 points. See these 2 points. So, these 2 points, you can pass a line through these 2 points. So, they lie on a line. So, they are collinear. So, we can say 2 points are always collinear. But 3 or more than 3 points, if they lie on the same line, suppose this is a line L. If I write here point P, here Q, here R. So, these 3 or more than 3 points, if they lie on the same line, then they are called collinear points. Otherwise, they are non-collinear points. See here, if I say these 3 points, A, B, C. You cannot draw any line which contains all these 3 points. Okay, all these 3 points. So, they are non-collinear points. So, in short, if 3 or more than 3 points lies on a same line, then they are called collinear point. Here P, Q and R, all these 3 points lie on a same line L. So they are collinear points. Whereas here A, B, C does not lie on a same line. So they are non-collinear points. Okay. Now intersecting lines and non-intersecting lines. See, I will draw two lines. One line, this is PQ. Another line I am drawing here, this is RS. So these two lines, PQ and RS, they meet each other at this point O, so they are called intersecting lines. In short, this O, point O, is on line PQ as well as point O is on line RS. So there is only one point O which belongs to both the lines. There is no other point except O which belongs to both the lines. So these two lines are called intersecting lines. And I will draw one more, see here. So there is no common point which belongs to both the lines. So they are non-intersecting lines. It means they will never intersect each other. If they do not intersect each other, then they are called parallel lines. Have you got, friends? So if lines are not intersecting, they are parallel. If lines are parallel, then they are not intersecting. It is vice versa. Okay? So if I say lines are intersecting lines, it means they are not parallel. If I say lines are parallel, then they are not intersecting lines. Clear? Now we will talk about angles. We have discussed one topic, that is lines, and now we will discuss about angles. What are angles? See, it is a figure which is formed by two rays with the same initial point. See, I will draw one ray here. This is one ray. I can say it is BA. B is the initial point, that is end point. And I will draw one more ray. This is I will say C. So there are two rays. Which are these two rays? We have two rays, that is BA and BC. These are the two rays and they have common initial point. See here, B is the common initial point. So a figure which is formed by two rays with same initial point is called as an angle. And the same initial point is called vertex. See, this B is called vertex. This B is called vertex. Okay, and the ray BA and BC, they are called arms. These are called arms. These two are called arms or sides. Okay, so we can say what is angle? So it is figure which is formed with two distinct rays having same initial point is called an angle, and same common initial point is called vertex. And two distinct rays BA and BC, they are called arms of an angle or sides of an angle. Now there are different types of angles. So now we will discuss types of angles based on measure. Based on measure. Types of angle based on measure. So first one we will see acute angle. You may be familiar with this acute angle. Acute means an angle whose measure is more than 0 but less than 90 is called an acute angle. See, this is acute angle. Okay, BOA, angle AOB. This angle is acute angle. For example, its measure is 30 degree. So its measure angle AOB, we can say it is greater than 0 degree but less than 90 degree is called an acute angle. So an angle whose measure is more than 0 degree but less than 90 degree is called acute angle. Now we will discuss second angle, that is called right angle. See, right angle. An angle whose measure is exact 90 degree. Exact 90 degree is called right angle. Here you see ray OA and ray OB. These two rays are perpendicular to each other. Why? Because they are forming 90 degree. And ray OB is perpendicular to ray OA. Ray OA is perpendicular to ray OB. So an angle whose measure is exact 90 degree is called right angle. Now comes third, obtuse angle. See, this is the classification of angle based on measure. See this angle. So here angle whose measure is more than 90 but less than 180 is called obtuse angle. So here we can say angle AOB is greater than 90 degree but less than 180 degree. So an angle whose measure is more than 90 degree but less than 180 degree is called an obtuse angle. Clear? So this is obtuse angle. You can draw in any way. See, this is also an obtuse angle. See, if I say P, Q, R, for example, I can say 120 degree. So 120 degree is more than 90 and less than 180. So angle AOB is obtuse, angle PQR is obtuse angle. Now comes fourth angle, that is called straight angles. Straight angle. What is straight angle? An angle whose measure is exact 180 degree is called a straight angle. Here we can say angle AOB is equals to 180 degree. This measure is 180 degree. Here you see two arms OB and OA are opposite arms. Have you got it? What do you mean by opposite arms? OB and OA, they are exact opposite arms. So that forms an angle 180 degree. Or we can say a straight line has two right angle. I can say, see, if I draw this is straight line. So this is 90 degree, this is also 90 degree. So a straight line has two right angles. This is called straight angles. Now we will learn fifth angle, that is reflex angles. Reflex angle. So an angle whose measure is more than 180 but less than 360. See, I will draw one diagram. You see here. If I say this is A, this is O, and this is B. So this angle is reflex angle. Okay. So an angle, for example, here say AOB. I have to write here reflex AOB. Why? AOB. This can also be angle AOB. See, angle AOB, but it is obtuse angle. Okay, so I have to mention here reflex angle AOB in order to avoid confusion. So its measure is more than 180 degree and less than 360 degree is called reflex angle. So here angle AOB, this is obtuse. Okay, this is obtuse. See, remember this is obtuse, whereas this is reflex. So our reflex angle AOB is this angle. Clear? So reflex angle AOB, his measure is greater than 180 degree, less than 360 degree. Okay, if I draw this diagram, see what you can say. Here, if I say this P, Q, R. Is this reflex angle PQR? No. Why? Because just by diagram only, mere by observation, you can say it is less than 180. So it is obtuse angle. This angle is reflex PQR. Have you got it? Now last angle, that is sixth angle, we can say complete angle. Complete angle. So I will draw the diagram complete angle. So complete angle means an angle whose measure is exact 360 degree is called complete angle. See, this is 360 degree. This is total 360 degree. So here which is angle which you can say AOA. See, for angles you require two arms. This way 2 arms you require. But here complete angle AOA means from here OA is one ray and OA is another ray, same ray. So this angle is called 360 degree. It is complete angle. Clear? So now we have seen types of angles. Once again I am going to recap all those angles. See here. First one, acute angle. Its measure is greater than 0, less than 90 is acute angle. Exact 90 is right angle. More than 90 and less than 180 is obtuse angle. Then comes straight angle. Exact 180 degree is called straight angle. Then comes reflex angle. Reflex means more than 180 and less than 360. This angle is called reflex angle. Okay. Then complete angle means 360 degree. Okay. So in short we can say, okay, in between 0 to 90 it is acute angle. Okay. And exact 90 it is right angle. Okay. Then 90 to 180 it is obtuse angle. Then exact 180 degree it is called straight angle. Angle of a straight line. Then we can say angle 180 to 360 it is called reflex angle. Okay, and 360 degree it is called complete angle. So this is the classification of angle based on measure. Clear? Now we will see pair of angles. Now we will see pair of angles. Pair of angles. Now see, first one we will discuss complementary angle. The name itself suggests complementary. So two angles are said to be complementary. Two angles are said to be complementary if sum of their measures is 90 degree. Means the total of two angles should be 90 degree. See, I will draw one diagram here. See, A, O, B. I will draw one here. C. See, for example, I can say this is acute angle 30 degree. This is also acute angle 60 degree. So total of these two angle is 90 degree. So here we can say angle AOC plus angle BOC is equals to 60 plus 30, that is equals to 90 degree. So sum of these two angle is 90 degree. So these two angles are called complementary angles. Okay, and complementary angles are always acute angles. Why? Because their total should be 90. Clear? Then comes second one, supplementary angles. Supplementary angles. So two angles are said to be supplementary if sum of their measures is 180 degree. Okay, so what are supplementary angles? See, I will draw one diagram. See here, A, O, B, and I have taken one ray here, C. Suppose this is 60 degree and this angle is 120 degree. So we have two angles, angle AOC, angle BOC. So here see, angle AOC plus angle BOC is equals to AOC is how much? 60 degree. BOC is how much? 120 degree. So the total is 180 degree. So these two angles are said to be supplementary because sum of their measure is 180 degree. So supplementary angles. Now we will discuss bisector of an angle. Third topic, bisector of an angle. So remember here, bisector of an angle. Say I will draw one angle AOB. I will draw one more ray. This is C. So this is a ray which divides a given angle into two equal parts. So here we can say ray OC divides angle AOB into two equal parts. So ray which divides angle AOB into two equal parts is called bisector of an angle. So here we can say OC is the bisector of an angle. So here we can say angle AOC, for example, this total angle is 60 degree. So this will be 30 degree and this is also 30 degree. This is 30, this is 30. So OC divides AOB into two equal halves. So we can say angle AOC is equals to angle BOC. They are equal and that is equals to half of angle AOB. So here ray OC divides angle AOB into two equal parts. So OC is called bisector of an angle. The name itself suggests bisector. Bisector means divide into two equal parts. Bisect. Bi means two, sect means part. So it is bisector of an angle. Now very important topic, fourth one is adjacent angles. Adjacent angles. See, adjacent angles. Now two angles are called adjacent angles. Two angles are called adjacent angles if, first condition, they have a common vertex. They have a common vertex. Second one, they have a common arm. Third one, their non-common arms are on different sides of the common arm. See, I will explain, no need of any confusion here. See, just if I draw, see this angle AOB and I will draw one more here, C. See here OC does not divide the angle into two equal parts here. Okay, it is not necessary always. It is not the bisector. Why? Because it is not dividing angle AOB into two equal parts. But here you see, we have two angles. One is angle AOC, another is angle BOC. In both angle, vertex is O. This is vertex, common vertex. So they have a common vertex. So first condition is satisfying here. Okay, they have common vertex. See, angle AOC and angle BOC, they have common vertex O. And second, they have a common arm. In this angle, you see ray OC, ray OC. So they have common arm. If we take angle AOC, it has one arm OC. If we take BOC, it has one arm OC. So it has a common arm. This is common arm. And OA and OB are non-common arm. And they are on either side or they are on different side of ray OC. See, this is ray OC. My pen is ray OC. Have you got it? This ray OC. So OA is on one side and OB is on other side of ray OC. So their non-common arms are on different side of common arm OC. So these three condition has to be satisfied. Once again, so these two angles are called adjacent angles. So when you can say two angles are adjacent angle, first condition, they should have a common vertex. Second condition, they should have a common arm. Third conditions, their non-common arm should be on different sides. So we can say these two angles are adjacent angles. See one more thing from here only. Just I will take two more angles. See, angle AOC and I will take angle AOB. See here, AOC and AOB. Have you seen AOC, AOB? So OA is a common arm and two non-common arm are OC and OB. See, OC and OB. These two are non-common arms, but these two arms are on the same side of common arm OA. So they are not adjacent angles. They are not adjacent angles. Have you understood? Once again, just you go. I have taken two angles AOC and another AOB. So here common arm is OA. Okay, and these two are non-common arm, but they are on same side. What is our conditions? Okay, their non-common arms are on different sides. So these two are not adjacent angles. These two are adjacent angles. Common arm is OC and non-common arms are on different sides. Have you got it? So these are called adjacent angles. See here in this case, if you want to see this is OC, angle AOC and angle BOC. OC is a common arm and these two non-common arms are on different sides. So these two angles are adjacent angles. Have you got it? So now linear pair of angles. Fifth one. Linear pair of angles. See here, angle A, O, B, and I will draw here OC. Are they adjacent angles? See here. Which are two angles? AOC and BOC. So OC is a common arm and these two remaining are non-common arm and they are on either side. But one thing have you noticed here? These non-common arms are opposite to each other. Here if I draw in this manner, see here. Okay, A, O, B and C. So this is common arm, angle AOC, angle BOC. So this is common arm, okay, common arm. But non-common arm, these two, this non-common arm are not opposite to each other. Here you see OA and OB, they are exact opposite to each other. These two are adjacent angles. These two are also adjacent angles, but they are not linear pair of angles. Why? Because non-common arms should opposite to each other. So two adjacent angles forms a linear pair of angles if their non-common arms lie on a straight lines or they are opposite to each other. Have you got it? Then we'll discuss sixth one, vertically opposite angles. Any confusion here? What do you mean by linear pair of angles? These are, see once again, adjacent angles. These are also adjacent angles, but they are not linear pair of angles because their opposite, their non-common arms are not opposite to each other. Here non-common arms are opposite to each other. So we can say if non-common arm of two adjacent angles forms a line, or they are opposite to each other, then these angles are called linear pairs. You can write definition according to your own words. You can say in this manner also. Okay. If non-common arms of two adjacent angles are opposite to each other, then they are called linear pair of angles. Now vertically opposite angles. See, this is vertically opposite angles. I will draw two lines. See, this one line I can say AB, second line I can say CD. and they intersect each other at O. So we can say if two lines intersect each other at a point, then there are two pairs of vertically opposite angles. See, these two are vertically opposite angles, and these two are also vertically opposite angle. Angle AOC, angle BOD, they are vertically opposite angles. Angle AOD and angle COB, they are also vertically opposite angles. So two angles are called a pair of vertically opposite angles if their arms form two pair of opposite ray. See, if I say angle AOC and angle BOD, angle AOC and angle BOD, their arm you see. AOC means one arm is OA and BOD, one arm is OB. So these two arms are opposite to each other. Here AOC, so one arm is OC, BOD, one arm is OD. So their arms are opposite to each other. So that is called vertically opposite angles, or in short we can say that when two lines intersect each other at a point, then there are two pairs of vertically opposite angles. Here one is angle AOC and angle BOD are vertically opposite angles, and angle AOD and angle BOC. So these are two pairs of vertically opposite angles. Have you got it? So in short, we have studied, once again if you want to recap, I will recap all these things. See, pairs of angle, complementary angle. I told you that two angles are said to be complementary if their total is 90. Supplementary angles, two angles are said to be supplementary if their total is 180 degree. Then we have learned bisector of an angle. So here, if a ray divides the angle into two equal parts, then it is called bisector of an angle. Adjacent angles, I told you, the two angles are called adjacent angles if three conditions are satisfied. First one, they should have a common vertex, they should have a common arm, and two non-common arms are on different sides of a common arm, then they are called adjacent angles. And fifth one, we have seen linear pair of angles. So linear pair of angles, I told you what are linear pair of angles. If non-common arms of two adjacent angles are opposite to each other, they are called linear pair of angles, vertically opposite angles. If two lines intersect at a point, then two pair of vertically opposite angles are formed. Okay, now last topic we are going to discuss about the relations. Relation between pair of angles. Pair of angles. See, relation between pair of angles. So we will learn one axiom. Very simple. See here, just see, this is a ray OC. If a ray stand on a line, then the sum of their adjacent angle so formed is 180 degree. This is first axiom 1. What I can say, if a ray stand on a line, then the sum of two adjacent angles, so formed is 180 degree. See here, this is a ray OC. This ray OC stand on line AB or not. So if a ray stand on a line, then these two adjacent angles are formed. Okay, so the adjacent angle so formed is 180 degree. Sum of these two adjacent angles so formed is 180 degree. Here we can say, see, angle AOC plus angle BOC is equals to 180 degree. This total will be 180. Why? Because they are the angles on straight lines. For example, this is 60, this is 120, so the total will be 180. So in short, we can say if a ray stand on a line, then the sum of two adjacent angles so formed is 180 degree. This is axiom 1. Now axiom 2. Axiom 2. It is just converse of axiom 1. I will explain it. See, if the sum of two adjacent angles is 180 degree, then the non-common arms of the angle form a line. Then the non-common arms of the angles form a line, or non-common angles forms two opposite rays. So I will draw the diagram. If I say sum of these two adjacent angle is 180 degree, I will say A, B, O, C. So if angle AOC plus angle BOC is equals to 180 degree, if this is the case, so this is common arm. In both the case AOC, BOC, this is common arm. So these two are non-common arms. Okay, so these non-common arms forms a line, or they are two opposite rays. So it is converse of axiom 1. What axiom 1 say? If a ray stand on a line, then the sum of two adjacent angle is 180 degree. Or if the sum of two adjacent angle is 180 degree, then we can say the non-common arms forms a line. So axiom 2 is totally opposite or converse of axiom 1. These two axioms at a time, it is called linear pair axiom. Axiom of linear pair or linear pair axiom. Have you got it, friend? What is axiom 1 and what is axiom 2? If a ray stand on a line, then two adjacent angles so formed, the total is 180 degree. Converse is, if sum of two adjacent angle is 180 degree, then two non-common arms forms a line. Now the last topic of your theory is one theorem we are going to learn. Very important theorem, see here. This is the first theorem of your syllabus, theorem 1. If two lines intersect each other, then vertically opposite angles are equal. This is theorem. So in theorem, first we will write given. What is given? So you read the statement. The statement of theorem is conditional statement. If two lines intersect each other. See, I will draw the diagram. See, these are the two lines. If these two lines intersect each other, I will say this is A, this is B, this is C, D. These are two lines and they are intersecting at O. So if two lines intersect each other, then you have to proceed. These are the vertically opposite angles and these two are vertically opposite angles. So if two lines intersect each other, then vertically opposite angles are equal. That you have to prove. So what is given here in our? So it is given that a line AB and CD intersect each other at point O. So we can say line AB and CD intersect each other at O. This is data given. Now what you have to prove? You have to prove that vertically opposite angles are equal. First one. So we can say which are vertically opposite angle? Angle AOC is equals to angle BOD. Second, these are also two vertically opposite angles. So we can say angle AOD is equals to angle BOC. This you have to prove. Now proof. How you will prove this? Proof. See here. There are two lines. First we will take line AB. Remember, first we will take line AB. See, if we take this line AB, then this ray OC stands on line AB. So I can say here, okay, ray OC stands on line AB. So according to axiom which we have learned, if ray OC stands on line AB, then we can say AOC plus BOC is equals to 180 degree. That is our first axiom we have learned here. See, first axiom that already we have learned. Just a minute. See, Axiom 1. If a ray stands on a line, say this is ray OC, stands on line AB, then sum of these two angles is 180 degree. This is axiom 1. So here we can apply that axiom 1. So ray OC stands on line AB. So we can say here angle AOC plus angle BOC is equals to 180 degree. This is one reason. What you will say? You can say by linear pair axiom. Linear pair axiom. You have to give the reason also. Okay, so what we have done here, okay, ray OC stands on line AB, so according to linear pair axioms, their total is 180 degree. Now same thing, now we have taken line AB, now second you will take line AB you have taken, now you will take line CD. There are two lines only, no? So first you will take line AB, so OC stands on line AB, now you will take ray CD, so OB stands on, ray OB stands on line CD. So if ray OB stands on line CD, then these two angles are linear pair angles. So we can say angle BOC plus angle BOD is equals to 180 degrees. Second, same thing, linear pair axiom. Have you got it, friends? First what you will take? You will take first line AB. Okay, first line AB. So OC stands on line AB and linear pair axioms. Then you will take line CD. If you take line CD, OB stands on line CD, so their total will be 180 degree. Now, this total is also 180 degree and this total is also 180 degree, so these two are equal, so these two will be equal. So, equating 1 and 2. This is 180, this is 180, so these two will be, LHS will be equal. So, I can say angle AOC plus angle BOC is equals to angle BOC plus angle BOD. Any doubt? Why? Because see here LHS, RHS. This is 180 degree, their total is 180 degree. Here their total is also 180 degree. These are equal, so these two will be equal. So I can cancel here BOC, BOC. So what will left? Angle AOC is equals to angle BOD. See here we have proved this. Angle AOC is equals to angle BOD. Similarly, this is the symbol for similarly. Similarly, you can prove angle AOD is equals to angle BOC. So, you have to write here in case of theorem, hence proved. So, this is the first theorem of your syllabus. The vertically opposite angles are equal. So, given is line AB and line CD both intersect at point O. And what you have to prove? You have to prove vertically opposite angles are equal. So, angle AOC is equals to angle BOD and angle BOC is equals to angle AOD. That you have to prove. Proof. What you will write? First you will consider line AB. So, first you will take line AB. So, OC stands on line AB. First line AB. So, OC stands on line AB. Then you have used linear pair axiom. Okay, if OC stands on line AB, then their total will be 180. Then you have taken line CD. OB stands on line CD, so their total will be equal to 180 degree. Then you have equatum both of them, BOC, BOC cancel, and your result here. So with this we have completed theory of lines and angles. Hope you have enjoyed this theory.